This is a front flip, an acrobatic movement where you rotate your body a full 360 degrees in a forward direction and land on your feet. A front flip is divided into four main sections: the takeoff, the tuck, the rotation, and the landing. Many people think that front flips are more of a physical activity, but I believe otherwise. I believe that physics take a huge part in learning a front flip. For example, did you know that front flips follow all three of Newton's rules? For example, Newton's first law: an object at rest will remain at rest, and an object in motion will remain in motion at a constant velocity, same speed and direction, unless acted upon by a net external force. This applies to front flips too. Your body wants to keep doing whatever it's already doing. If you're standing still, you stay still, unless you push off the ground. But if you're moving upward and rotating, you will keep rotating until something stops you. Newton's second law states that the acceleration of an object depends directly on the net force acting on it, and inversely on its mass. In simpler terms, it means that heavier objects require more force to accelerate, and pushing an object harder will make it speed up. Also applies to front flips. To start a front flip, your legs push against the ground, making you jump. The more force you give, the higher the acceleration, and the higher the acceleration, the higher you jump. Newton's third law: every action has an equal and opposite reaction. This law is what makes you jump. When you put force on the ground, it pushes you back, making you jump. So I've tried learning a front flip before, but I failed. So I got this idea. What if I try learning the physics behind a front flip and see if that will help me get better at doing a front flip? So over the next few days, I researched it. First, I wanted to find out what actually makes you flip. And I found out that what actually makes you flip in a front flip is torque. When you jump, if you only push straight down on the ground, you'll go straight up. To start flipping, you have to create a twisting force by leaning forward and swinging your arms and hips. This twisting force is called torque, and it starts your rotation. Once you're in the air, there's almost nothing to stop that rotation, so you keep spinning because of angular momentum. If you don't know what angular momentum works, it's fine, because I didn't know it either, so let me explain it to you. Angular momentum is basically the rotational version of momentum. Just like regular momentum keeps an object moving in a straight line, angular momentum keeps an object spinning. Angular momentum is a spinning motion around your center of mass, and moving your body closer to or farther from its center of mass changes how fast you rotate. That's why gymnasts tuck to speed up and open up to slow down before landing. Your center of mass goes through the air in a curve, while the rest of your mass spins around it, making you spin. Next, we have to find out what moment of inertia is. Moment of inertia is basically how hard it is to spin an object around its center of mass. The farther an object mass is from its center of mass, the larger its moment of inertia is, and the harder it is to rotate. The closer the mass is to the center, the smaller the moment of inertia is, and the easier it is to rotate. This is the reason why you have to tuck when you are doing a front flip. If you don't tuck, you will spin slower, thus not giving you enough time to do a front flip. Now let's move on to energy transformations. Before the jump, chemical energy is stored in your muscles. During takeoff, chemical energy transforms into kinetic energy. As you rise, kinetic energy transforms into gravitational potential energy. At the top, you get maximum potential energy. And as you fall, potential energy transforms into kinetic energy again. And now, the most important of all, landing safely. When you land, your momentum must be reduced to zero. Bending your knees increases the time over which you stop. This reduces the force on your body because longer stopping time is equal to smaller force. That's why gymnasts and parkour athletes bend their knees on landing. Now, since I know the physics behind front flips, I need to implement them into my front flips. And I figured the best way to do this would be to calculate at exactly which time do I have to move into each phase of a front flip. First, I calculated my air time by measuring how high my center of mass rises before the trampoline. I could use gravity to find out how long I'm in the air. For example, if my center of mass rises to a high h, the total air time is t equals 2 times the square root of 2h divided by g. This tells me exactly how many seconds I have to complete the flip. Next, I calculated how much angular momentum I create at takeoff. This depends on how much torque my body produces as I leave the trampoline. Angular momentum is related to my moment of inertia and rotation speed. L equals I times omega. Then I estimated my moment of inertia in different positions: open body position and tucked position. My height, weight, arm length, leg length, and body proportions all affect these values. Since angular momentum stays nearly constant in the air, I could calculate how fast I rotate while tucked and while open. If I know my tuck rotation speed, I can determine how long it takes to rotate 360 degrees. For example, first step is calculate airtime, then calculate rotational speed when open, then calculate rotational speed when tucked, add up the amount of rotation during each phase, solve for the exact moment I must tuck and the exact moment I must open so that the total rotation equals 360 degrees right as I land. So the basic idea is gravity gives the airtime, torque creates the angular momentum, moment of inertia determines the rotation speed, and conservation of angular momentum connects all the phases together. Using those pieces, I can calculate exactly when each movement in the front flip should occur. Before I continue, I just want to make sure to point out that I did not calculate all of this by myself. A lot of it used the help of Google and ChatGPT. I'm not some mega genius, even though a big part of it was my work. So, a rough timeline might look like this. The first 0 seconds, leave the trampoline bed. 0.10 to 0.20 seconds, throw my arms, bring my knees up, and tuck. 0.20 to 0.70 seconds, stay tucked and rotate. 0.70 to 0.90 seconds, start opening up once I can see the trampoline coming back into view. 0.90 to 1.20 seconds, finish the rotation and prepare to land. And 1 second to 1.50 seconds, land depending on how high my bounce was. Even though I can't count milliseconds while doing a front flip, I can film my front flips, examine them, and change them. So today I have taught you and myself the physics of front flips. If you want me actually to try learning front flips using the calculations that I just did, then make sure to comment down below, leave a like, and I will see you in the next one.